my channel. I'm Saiasmi Gupta and I'm 11 years old. I am the co-founder of tennisforthekids.com, and today we are going to be learning 4 important concepts of class 7th computers, because sometimes people learn these concepts and these concepts are not to be learned. These concepts are to be understood, right? So we are gonna do this. So we are gonna learn how to convert decimal to binary, binary to decimal, binary addition, and binary subtraction. So right, I think some of you might have already learned this for your exams, but still, for ahead, I'm gonna teach you a very cool trick, and from this you're never gonna forget it, and it's not learning, it will be so easy and so fun, right? So let's just get started. Okay, guys. So first of all, we are going to learn how to convert decimal to binary. Page 11, and this is, we're going to take example is 126, right? So open your book on page number 11 and you'll find this example, okay? And we're gonna take this example and I'm gonna be referring to the book, so that I'm gonna see and tell you the examples which are given in your book, right? So here we have the example of 126. So 1 2 6, right? And here we're gonna divide it by 2 and along the line, okay, and then we're gonna divide it. So we will get 12 divided by 2 is 6, and 6 divided by 2 is 3. Okay, now we've got 63. So now we're gonna divide it by 2. Even though it's not divisible, we are gonna do it. Oh wait, so first we're gonna have to write here remainder. So here we did not, after dividing it, we did not get any remainder. We got 0 as the remainder, so we are gonna write here 0. Okay, you will find this out very handy when we go ahead. Okay, 0. Then when we are dividing 63, so we get 3 and 1, 31, with the remainder of 1. Okay, really sorry about it being a bit messy, right? But hope you are able to understand. You can also be seeing your book side by side. Okay, so 1 and 1 down, and 5, 15, yes, 15 with remainder 1. Okay, now again 2. So we have to keep on dividing it until and unless we get 1. Okay, 1 second. So here we have got 15, right? So now 15, so we have 14, and then we'll have the remainder as 1. Yes, okay, and then another 2, and 2 3s are 6, right? 2 3s are 6, and here will be 3, and we again got remainder 1, and then again by 2, and here we'll get 1, right, with the remainder 1, right? So you might be thinking, after dividing, what have we got? What did we get? We did not get the binary form of 126. So we have got it. So we have to write this upside down. These numbers, the remainders is the binary form, right? So here we'll write 1, 1, 1, first this one, then this one, then another one, then another one, then another one, then another one, I just left a space here by mistake, so I'm just gonna write the 1 here, and then 0, and yes. Okay, so this is binary form of 126. You can also see in your book it's written the binary equivalent of 126 is 111110, right? Okay, so I hope you understood. So here it was very easy. What you had to do is the number that you have gotten, you have to divide it all by 2 and write the remainders as you go on till you get 1, right? So here first you will then your binary will start. First you will write this one, then this one, then this one, and then all the remainders as it goes, and it has to be upside down, right? Now I'll tell you one more thing, that ahead when we are gonna do binary addition and subtraction, we will see the binary form of 2 and 3, right? So can you anybody tell me the binary form of 3? Pause this video and write it on the comments. Okay, I'm gonna give you 5 seconds. 5, 4, 3, 2, and 1. Okay, I hope you have done so. So the binary form of 3 will be 11. Binary form of 3 will be 11. You know why? You don't know why? I'll tell you. Because if you see here, if you multiply 63 by 2, so 2 3s are 6 and 2 6s are 12, right? So here we are getting, by multiplying these both, we are getting this number, right? So when we multiply 2 and 1, what do we get? We get 2, right? With remainder 1, right? So with remainder 1, so plus 1 will be equivalent to 3, right? 3. So here we'll write these both remainders, okay? So I'm just gonna clear this as it's very messy now, or I'm just gonna do Control Z. Okay, 1 second. Okay, now so the binary form of 2 will be equals to, so you'll see here, we'll divide it by 2, and what will we get is 2 divided by 2, we'll get 1, right? Because 2 is divisible by 2, so we'll get remainder as 0, right? So 1 and 0, so 1 0 is the binary form of 2, and 1 1 is the binary form of 3. Okay, got it? Perfect. So I hope you understood this very easily. It was a very easy concept, right? So let's just recap again. How it was done is that we have to divide the number by 2 until we get 1, and then we have to do then we'll have to take 1 and then all the remainders upside down. Okay, so that's how it's done. Okay guys, very easy. I hope you understood. Okay, so okay, now let's do so now what we're gonna do, oh, 1 second, where's the select option? Once again, right, so sorry. So I'm gonna edit it, and binary, what we have now, we are gonna learn how to convert binary to decimal. So delete. Okay, so this example was on page number 11. Okay, now what we're gonna do is how to convert binary to decimal. Actually, this is my favorite because it's so easy and so fun to do. Okay, so again, it is on page number 11, right? An example that we're gonna take is gonna be 101. Okay, so you might be seeing this is in the book, right? This is the example, so we are gonna convert this. So this is super easy. Actually, it is one of my favorites. So how you convert a binary to decimal is the following way. So you have to first count the number of digits. Here we have 1, 2, 3, 4, 5 and 6, right? So total number of digits we have is 6, right? But if you remember, if you have seen my Python videos, we know indexing. What is indexing? If we have this, so index 0 will be this, index 1 will be this, index 2 will be this, and so on, right? So indexing starts from 0, right? So this is a bit messy. So right, we are gonna do it the same way. We are gonna take it by 0. This will be 0, this will be 1, 2, 3, 4, 5. Now you will be thinking, why in the world am I doing this? Okay, so we are coming to that now. So now we have got till 5. So you see the last number here, we have 5, right? So what we are going to do is 1, we'll multiply all these with 2 and raise to the power whatever these are, right? So these are the powers. No, these are known as exponents, right? So 1 into 2 to the power 5, right? So 5 is our exponent. 5 is our exponent. One second. Exponent, right? And 2, one second, we spin. And 2 is known as our base, right? And together 2 raised to the power 5 is known as power, right? So we are gonna learn this in class 7's maths chapter exponents and power, right? So if we just remove all this, so what we are gonna do is multiply all these 6 digits. We have a 6-digit binary number here. So we are gonna multiply all these 6 digits and we're gonna do the power as a power which we have written here, right? Because if we start from 0, whole numbers, if we start from 0 and take our way till the last number, in this example we are getting 5. So first we are gonna multiply. So we are gonna start multiplying from this digit, right? So 1, and we are gonna multiply with 2. So 1 into 2 to the power 5 plus 0 into 2 to the power 4, right? Because over here 0's power will be 4. Then plus 1 into 2 to the power 3. Okay, because 1's power is 3 over here, this one power is 3. Then 0 into 2 to the power 2. I'm really sorry for it not being straight and messy, but the point is of understanding, right? Then plus 1 into 2 to the, no wait, sorry, what am I doing? Here after 0 we have another 0 which power is 1, so we are going to multiply it with that. So 0 again into 2 to the power 1 plus 1 into 2 to the power 0, right? So now how do we calculate when we have this to the power this, right? So you might not have been taught this. So this is done. Now in coding we have already done this. But if you have not seen my videos and if you are not, for example, passionate about coding, so we know that 2 to the power 5 is equals to 2 into 2 into 2 into 2 into 2, right? So basically any number raised to the power anything, right? So here we have the example of 2 raised to the power 5, right? So it means that the base, hence 2 over here, will be multiplied by itself 5 times, right? Here we have written 5 times 2. 1, 2, 3, 4, 5. So you see here, we are multiplying 2 with itself 5 times, right? So that is known as power. So 2 raised to the power 5, extended form is 2 into 2 into 2 into 2 into 2. So let's calculate. What do we get? 2 into 2 4 into 2 8 into 2 16 into 2. Let's do 16 into 2. 6 2s are we get 12, and 2 into 1 2 plus 1 3, right? So here we get 32, right? So this is how it is done. So I'm now gonna make it a bit beautiful because it's kind of messy, don't you think? So here, this is equals to 32, right? Plus 2 into 2 raised to the power 4 will be equal to 2 into 2 into 2 into 2, right? But here we are multiplying it with 0. So we don't need to calculate it because anything 2 to the power 4, whatever we'll get, which is we know 16, we'll have to multiply it by 0, which we'll get 0, right? Then we'll calculate this because here we are going to multiply it. So 2 into 2 into 2, very easy. 2 into 2 4 into 2 8, so we get 8, and into 1 will be 8 only, right? 32 plus 8. Then here we know 2 to the power 2 will be 4, but into 0 will be 0, plus 2 to the power 1, basically 2 will be multiplied only 1, so 2 itself, it will be only 2, right? So 2 into 0 will be 0, right? Now this is very tricky. You will be thinking 2 to the power 0, that means 2 into 0, which is 0, and 0 into 1 is equal to 0, hence we'll write here 0, and then what we'll get is 40, right? You think that? Nope, it's wrong. This is not how it will be done. Now, I'll tell you. So, any number to the power 2, it can be any number, 3 to the power 0, 4 to the power 0, 5 to the power 0. Any number to the power 0 is equivalent to 1. It will be always equivalent to 1. So here we have 2 raised to the power 0, it will be equals to 1. 3 raised to the power 0 will be equals to 1, right? So this is how it will be done. Any number raised to the power 0 will be equals to 1. This is an important thing you should remember, because sometimes you make a mistake and all this calculation will go wrong. Because what you will get if you write here 0 for chance, so you will get 40, which is wrong. It is wrong. Your answer 2 raised to the power 0 will be 1, and what you will get 32 plus 48 plus 1 will be 41. So just of this calculation and just because of 0, you will get it wrong. So keep in mind, any number raised to the power 0, not only 2, any number raised to the power 2 will always be 1. Okay guys? So this was also on page number 11 and such easy, right? In this what you have to do, this is more easier than that decimal one also, I think. Because in this what you have to do, you have to basically multiply all the digits by 2, count the number of digits, and then and then just give this the ones place will get here 0, then 1 and 2 and 3 and 4. So to make it easy for yourself only, what you always do is, wait, what you always do whenever you get a question is that count the number of digits. 1, 2, 3, 4, 5, 6. We have got 6 digits here, and then over here this first digit, the at the most right hand side, will get here 0, 1, 2, 3, 4, 5. So start the counting from 0 and assign 0 as the power to the rightmost digit as we saw, and then when you multiply 1 into 2 to the power 0, you will get 1. Okay guys, so that's how it is done. Now one more thing. If for example you are given 2 into 3 to the power 0, what will you do? What you will do is you will write 0, which is wrong. What did I tell you? 2 into 3 to the power 0. First see that 3 to the power 0. If any number raised to the power 0 will be 1, right? So now you have to multiply 1 into 2. What will you get? You will get 2. Simple, right? So that is how it is done. Hope you guys liked it.